Without warning, the sky over central Oklahoma turned into a nightmare. A dark wall of rotating clouds swallowed the horizon as storm chasers accelerated down rain-soaked highways, convinced they could stay ahead of the storm. Then the tornado did something almost no one expected. It suddenly changed direction, expanded to an unimaginable size, and transformed one routine intercept into one of the deadliest days in storm chasing history. In just a few terrifying minutes, America's widest tornado would prove that even the experts can be caught off guard. It was May 31, 2013. Only 11 days had passed since the devastating Moore EF5 tornado had struck Oklahoma. The atmosphere was once again primed for violent weather. The National Weather Service warned that warm, moisture-rich air from the Gulf of Mexico was colliding with cooler, drier air sweeping across the southern plains. Powerful wind shear created ideal conditions for rotating supercells capable of producing large and destructive tornadoes. By late afternoon, towering thunderstorms exploded across central Oklahoma. One supercell, southwest of Reno, quickly became the focus of meteorologists. Doppler radar detected intense rotation inside the storm, while emergency managers issued tornado warnings across Canadian County. Sirens echoed through nearby communities as residents rushed toward basements and storm shelters. At approximately 6:03 p.m., the tornado touched down west of Reno. At first glance, it appeared relatively narrow. Storm chasers moved into position, believing they had safely anticipated its path. Cameras rolled from multiple directions as researchers collected valuable atmospheric data. Among them was the respected Twistex team, led by meteorologist Tim Samaras, whose groundbreaking research had helped improve tornado science for years. Then, everything changed. Within minutes, the tornado expanded at an astonishing rate. The condensation funnel widened while an enormous circulation developed around it. Heavy rain wrapped around much of the storm, hiding its outer edges from view. From several miles away, many observers could only see a single dark funnel, unaware that the tornado's true circulation extended far beyond what was visible. Mobile Doppler radar soon recorded extraordinary wind speeds approaching 295 miles per hour, among the highest ever measured on Earth. Yet despite those incredible winds, the tornado would later receive an EF3 rating because the enhanced Fujita scale is based on damage to structures rather than directly measured wind speeds. Since much of the tornado crossed open farmland, there were fewer buildings available to indicate its full strength. The tornado continued growing until it reached an astonishing width of nearly 2.6 miles, making it the widest tornado ever documented. Inside the enormous circulation, multiple subvortices spun around the main funnel, creating pockets of even more violent winds. What appeared to be one tornado was actually a constantly shifting system, capable of changing shape and direction within seconds. Storm chasers suddenly realized they were in far greater danger than expected. The tornado unexpectedly turned southeast, moving across muddy roads and directly toward several chase teams. Powerful inflow winds shook vehicles while sheets of rain reduced visibility to almost nothing. GPS navigation became difficult as roads flooded and debris filled the air. One experienced chaser later recalled that the storm no longer looked like a tornado. Instead, it appeared to be an entire rotating thunderstorm moving across the landscape. Others described watching fields disappear beneath a massive wall of rain, wind, and debris. The tornado's true size made judging safe distances nearly impossible. For the scientists pursuing knowledge that could one day save lives, the danger was becoming overwhelming. What happened next would forever change the world of storm chasing. As the massive circulation continued across the Oklahoma countryside, escape became nearly impossible for several storm-chasing teams. The tornado wasn't just growing larger, it was changing direction without warning. Instead of following the expected northeast track, it suddenly veered to the southeast. At the same time, multiple subvortices raced around the main circulation at incredible speed, producing bursts of extreme winds far outside the visible funnel. Even experienced meteorologists struggled to understand exactly where the tornado ended and where safety began. Then, the worst happened. The enormous circulation overtook several vehicles. Among those caught in its path were legendary storm researcher Tim Samaras, his son Paul Samaras, and fellow meteorologist Carl Jung. For years, Tim Samaras had dedicated his life to understanding tornadoes, developing instruments that helped scientists improve warning systems and save lives. Despite decades of experience and an unmatched reputation for caution, the unprecedented behavior of the El Reno tornado left almost no opportunity to escape. All three lost their lives that evening, sending shockwaves through the meteorological community. When the storm finally weakened, after nearly 40 minutes on the ground, emergency responders began searching through the damage path. Sheriff's deputies, firefighters, paramedics, and volunteers worked through darkness and dangerous weather to reach stranded motorists and damaged rural properties. The tornado claimed 8 lives, injured more than 150 people, and damaged or destroyed numerous homes, farms, power lines, and businesses across Canadian County. Property losses exceeded $35 million in 2013, equivalent to well over $45 million today after inflation. As investigators surveyed the storm, scientists confirmed what many had struggled to believe. The tornado had reached a maximum width of approximately 2.6 miles, making it the widest tornado ever officially recorded. Mobile Doppler radar also measured winds approaching 295 miles per hour, among the highest ever observed on Earth. Yet, because the tornado struck relatively few engineered structures capable of revealing the full force of its winds, it remained officially rated EF3 under the enhanced Fujita scale. The event reminded both scientists and the public that a tornado's official rating does not always represent its true atmospheric intensity. The tragedy transformed the storm-chasing community. Researchers began placing greater emphasis on escape routes, storm evolution, and maintaining larger safety margins during rapidly changing situations. Forecast offices also expanded research into rain-wrapped tornadoes, multiple vortex structures, and sudden changes in tornado motion. The El Reno tornado became one of the most studied severe weather events in American history, helping improve forecasting techniques that continue protecting lives today. One survivor later described looking back after reaching safety and realizing the tornado filled nearly the entire horizon. Another first responder recalled the silence that followed once the wind stopped, a silence broken only by emergency radios and distant sirens. Those moments served as a reminder that behind every statistic are families, friends, and communities forever changed. If you ever receive a tornado warning, don't wait until you can see the funnel. Many of the deadliest tornadoes are hidden by rain or darkness. Go immediately to a basement or an interior room on the lowest floor of a sturdy building. Stay away from windows and monitor trusted weather alerts until officials declare the danger over. Preparation takes only minutes, but it can save your life. If you enjoy uncovering the true stories behind America's most extraordinary disasters and the people who faced them, subscribe to American Disaster Files and leave a like. In our next documentary, we'll investigate another unforgettable weather event that challenged science and revealed the incredible power of nature. The El Reno tornado will always be remembered for its records. It was the widest tornado ever measured and one of the strongest ever observed. But its true legacy reaches far beyond numbers. It changed how scientists study tornadoes, how storm chasers approach danger, and how communities prepare for the unexpected. On that dark Oklahoma evening, nature reminded the world that even our greatest knowledge has limits, and that respect for its power remains our greatest defense.